Welcome to section 9.4, Formulas and Applications. So now we're going to start using the quadratic formula in some new ways. First off, let's deal with some formulas. So this is a formula, specifically it's a formula for the area of a sector of a circle. It's like a pie slice is the way you might want to think about that. So, but if I want to solve for r, that means I want to eventually have r is equal to some value. Well, how are we going to do that? Well, we have to peel off the layers just like we do normally. So first, let's take care of that 1/2. The opposite of multiplying by 1/2 is multiplied by 2. So multiply both sides by 2. I get 2a equals r squared theta. So this is the symbol of theta. So if I want to get this over here, the opposite of multiplication is division. So I divide both sides by theta. And I get 2a over theta equals r squared. That's pretty good. But now how do we finish getting r by itself? Well, the opposite of squaring a number is to take its square root. So r is equal to plus or minus the square root of 2a over theta. And we could rationalize the denominator. I'm not going to for this particular one. But that's just the idea, is we're just solving for specific variables. So I want you to pause the video and solve this again for r. This is the volume of a cylindrical cone. So go ahead. Well, the first thing we can do, since you prior worked through it, opposite of dividing by 3 or multiplying by 1/3 is multiply by 3. Just multiply both sides by 3. Now I can divide, notice pi and h are both multiplying r squared, so I can divide by both of them and then take the square root, and we have the plus or minus all of this. So this is the general idea about how we can solve. Let's take it to another level. What about this? So here's my formula. You don't even need to know what it's for, but I want to solve for y. So I got y hanging here, y squared, and y. Well, notice the way that I organized it, 3 is kind of like the coefficient of y squared. So it's my a. What's your b then? Careful, it's not just 2 because it's 2f. F is also in here. And c is negative 7g because it's everything here. So essentially we treat everything except for y as a constant. That's just the general rule, is we're treating everything else as a constant. And we're going to solve. So if I put all these together, can I just plug them into the quadratic formula? Sure enough, I can. And then all it's just about is plug and chugging. So the negative turns into negative 2f. 2f squared is 4f squared. You multiply all this together and you get positive 84g, and 2 times 3 is 6. And we're going to go on and use another theorem. So that idea of all of the formulas, we're just going to solve for specific variable. So the Pythagorean theorem is the next thing we're going to deal with in this section. Well, the Pythagorean theorem is a very good application of quadratics. What is the Pythagorean theorem? Well, Pythagorean theorem is this. If I have a triangle, so this thing right here, and it has legs A and B, so that's these sides, and C, then a squared plus b squared equals c squared. And actually, if I have a triangle where this squared plus this squared equals this squared, then it is a right triangle in the same way. So this is a really powerful theorem. It's exceptionally powerful in geometry. And it also has other applications. But let's just kind of work through getting you a little familiar with it. I'm not going to give you the proof. You can Google it. There are more than 90 different proofs of this, including one by a president of the United States, Grover Cleveland. So just to show you how to use it, let's start with I want to find b when c equals 26 and a equals 24. So again, this is my formula. So I'm just going to literally plug in a and c, and I get like this, 24 squared plus b squared and 26 squared. Now I want to solve for b squared, and I can't just square root everything. I actually have to square these things out, move them to one side, and take the square root. So if I square both sides out, I get 576, and this is 676. Move them over, and you get 100. Take the square root, and we're left with b is equal to, what's the square root of 100? It's 10, but notice I didn't include a negative. Normally we have a plus or minus. Why did I only do the plus? Well, if you remember back to the last slide, it's a length. There is no such thing as negative length or distance. We only have positive length and distance. So if you don't believe me, you can watch some great movies such as Ferris Bueller's Day Out, where he learns that you can't make a car's odometer go backwards because there is no negative distance. So this idea is just isolating and solving for one of these that we may or may not know. Well, here's an actual application problem. So suppose I have a triangular chunk of land. I know it's a right triangle. By the way, as soon as you hear right triangle, you know that the quadratic formula can apply. And I have a perimeter. The perimeter is 72 yards. Well, let's start drawing a picture. So here is my triangle, sides A, B, and C. So my legs, if I say that this side is x, B has to be x minus 6 because it's 6 yards shorter. I just arbitrarily chose which one was which. So if A is x, then this is x minus 6. Well, if I know this and this, the question is, well, what's C? Well, we have something that's called the perimeter, 72. How do you find the perimeter of a triangle? You add up all the lengths of the sides. So A plus B plus C equals 72. But I know that what A and B are in terms of x, so if I plug those in, notice, can I solve this equation for C? So pause the video and solve that equation for C. All right, I'd combine like terms over here. So x plus x is 2x. And you got just the minus 6. And then, so C, if I move everything over, add 6, I get 78, subtract the 2x, and I get minus 2x. So I have that C is 78 minus 2x. Well, now notice I have A is in terms of x, B is in terms of x, and C is in terms of x. That is really, really good. So we can, using those, we can use the not the quadratic formula, we can use the Pythagorean theorem to plug in these values, because remember, a squared plus b squared equals c squared by the Pythagorean theorem. Now, I'm going to pause real quick and make a note. These a, b, and c, we use the same variables for the Pythagorean theorem as we do for the quadratic formula. That is just circumstance. They are not the same, so do not get confused by that. Now, how would you solve this equation right here? Hopefully you're saying I have to multiply it all the way out, and indeed you do. So x squared is x squared. X minus 6 squared, well, I did x minus 6 times x minus 6. And I multiply that, and I got here. Again, 78 minus 2x times 78 minus 2x, and I got all this. If I combine like terms, I get 2x squared minus 12x plus 36. And 6,084 minus 312x plus 44x squared. So that was just combining terms. So that was a big ugly mess. Now we're at this point, what could you do to solve this equation? There's lots of different options. You can use the quadratic formula, we can try factoring, we try completing the square. The simple fact is it's a nice form, but every one of those strategies we've used thus far has always required us to start off by making it equal to 0. So we need to move everything over to make it equal 0. Without lack of generality, I'm just going to move everything over to the left-hand side. That's how most of you like to do it. You could move everything over to the right-hand side and you'd be the negative version of this. But now that I did this, even before I start doing the quadratic or anything else, I would factor it, because if I can make those numbers smaller, that's always better. So what can you factor out of all three terms? We can factor -2, and that would turn this into -150, so that's a typo, minus 3024. So if we do that, if we plug all this in, that actually would turn into positive 150, and I'll talk about that. Clearly I have an issue that's messing up everything else. But now it's just a plug and chug matter. So I take this, take square roots, and so forth, and we get this. Now, if you're looking at it, you can quickly realize that I have two answers for this. Either I have the plus version and the minus. I'll even go back. You guys can see. So I plugged and chugged. This turns out to be a nice perfect square. It's 186. So I just kind of took that square root. Once you're in this phase, we can break it up like we've talked before, and now we can talk about how to do each of these. So this, if I do that subtraction, I get 36 over 2, and this is negative 336. Well, this is negative, which means it's negative length. So I'm going to ignore that, and I'm just going to focus on this 18. So if I get x equals 18, what are my other sides? Well, remember, b was that number minus 6, so 18 minus 6 is 12, and c was 78 minus 2 times 18, which is 42. So piecing all that together, that's pretty good. So we end up with 18 yards, 12 yards, and 42 yards as our final answer. And we can check it satisfies, that they all have the same perimeter, and things like that. So we can double check to make sure all this works, but that's how we did it. Okay, so I'm going to pause the video because I'm going to come back with more general applications of quadratics. Come back and watch the second part to learn even more applications.